suspense, we've been telling you about a Swiss man who was at contact with what he says are over 100 times with aliens from a place called Plejadiern, which is a planet somewhere in our galaxy out there. And he's just published a book with all kinds of pictures and all kinds of texts about that contact he's had.
By a Swiss farmer named Billy Meier. Meier has hundreds of other photos and some metal fragments from the spaceship. The photos that are not in the current book are still being tested, and so are the metal fragments. Marcel Vogel, a research scientist with IBM, tells us about one piece of metal that he examined under an electron microscope.
It's a very unusual combination from a metallurgical standpoint. I've shown these to metallurgists, and they shake their heads. And the most unusual thing is the purity of these metals in adjacency to one another without their cross-contamination. They're very sensitive to light, and as soon as I expose them to intense light from my microscope, the metal oxidizes very rapidly and just breaks down. I've never seen that. This really took me back. That only happened on Friday. And I'm going back in tonight. I'm having another go at observing and measuring that.
Okay, Dr. Vogel, could you tell us about your background briefly?
I'm a senior scientist with IBM in the General Products Division laboratories at Monterey and Cottle Road. My work has been from earliest childhood in the study of the conversion of energy inside of crystals. I started at the age of 7 on the exploration of bioluminescence, the firefly, the light of the firefly, and by 11 I was synthesizing the chemical that made the firefly glow, the 3-amino-thallose 1,4-dione. It's a chemical analog to that which is in the firefly, and from that point on I've focused my life on the study of luminescence, the conversion of energy in crystals. The materials that are in your color television, that are fluorescent lamps, and built my own corporation in this, and then developed for IBM the magnetic disk coding memory system, which now IBM uses throughout the world in their disk memories. I've developed the coding. We hold the basic patents for this material, and I've been into the field of material science all of my life. This is the letter that was sent to me by Mr. Wendelle Stevens, and I indexed each of the type of specimens with a code number. The photomicrograph under low power is shown here of the specimen, and I've taken and given to each discrete area a index number. Magnification is 8 diameters. The physical specimen was almost identical in dimension to what you are seeing here. Very much alike. This is another specimen. Now, we took under polarized light and examined. This is under just reflected light coming in at an oblique angle. Very interesting thing is the goldish area here, there's silvery, but also these peculiar flow lines coming. Distinct area. We'll analyze around. We're in the metal. There we see it. This is the boundary of the plastic. We're into the metal area here. This is number 4. This is the boundary in the plastic. Rotate the analyzer. We can bring it out. Here we are. There are 2 distinct areas here. These are the marks in the center of the picture again for Vickers hardness measurements. You can just see them. These were done in Switzerland. This will be reported on separately. In this crystalline area, the predominant element was silicon, which is this band here, and iron, and there was a secondary band of sulfur, which is right here. These were very, very intense bands, and we did not attempt to go through the analysis of all the other particular lines that were present. We just took the three main ones, and we stopped there.